Now let's look at how we can extract data from data frames. There's a lot of ways that we're going to be able to do this, but the three most common we'll use in this class is either grabbing the first or last n rows in a data frame. We might also want to grab data with a certain label. And finally, we might want to grab data at a certain position. All of these are going to be useful in different contexts. So the simplest scenario is just to grab the last n or the first n rows of a data frame. And that's with the .head and the .tail methods. So if here's our original elections data frame, this is what I get if I do .head versus .tail. And I'm going to go over to the notebook here. This is the same one we've been working in, the pandas data structure, and you're going to scroll down until you get to the slicing and data frame section. Here we're just loading the elections data here. And then notice I can change the values if I want to say, for example, the top 13 values. There we go, or the top 13 rows. And if I want to see like the last 9 rows, heads and tail are great for this. Now, if I want to do something more specific, we're often interested in what's called label-based extraction. So I'm going to jump back to the slides, but I would encourage you to actually run through this in the code while I'm doing this in the slides. The idea with the loc operator is we're going to be using the labels, which are the row labels is the same as what we typically call the index, and then the column labels are names of the columns. We'll be using that to describe and to access specific data in a given data frame. Loc allows us to input either a list, a slice, or a single value for the row labels and the column labels. So let's go through this explicitly. If I want to give a list for row labels and a list for column labels, then I can put both of those in to the loc operator, and I will get out specifically the data that matches those row operators, or those row labels and those column labels. If instead I want a slice, and so a slice in this context is denoted by a colon, and that's going to mean start at popular vote and then pull out or continue with each column you get until you end with the column percent. So slice always gives you a starting column and an ending column. When you're using a slice with loc operator, it's going to be inclusive of the left and the right hand side of the slice. So I will get this as my output. And then I can also use a slice to extract all rows or all columns. In that case, I'm just using a colon because it's telling me pull everything. And here's a way to do it with just pulling all the columns. If I put in a single value, so let me show you two different types of quote single values. If I don't put a list in for the columns and I just put a single column, then my output is going to be a series. And I can tell it's a series because the format is more of a flattened look when it gets output to me. If I had wanted that instead to be outputted as a data frame, we could have just put this single column name into a list, and then I would have gotten a data frame as an output. So you can try that, but if you leave it not in list form, you're going to get a series out. And then finally, if I want one entry, value of an entry in my data frame, this is saying go to the row label 0, the column label candidate, so I'm going here, here, and then pull out the entry, which is giving me Andrew Jackson. If I don't want to select just by labels, I have a third option, and that's using integer location. So the integer location is basically internally stored in Python when you load a data frame. What that means is I load a data frame, and regardless of what my actual index looks like, so this is my actual index, which in this case happens to just be integer labels as well, but I could have reindexed or picked something different that wouldn't match those integer labels. So regardless of what my index is, there's an internal row integer position that Python keeps track of what row you're in and what column you're in. And so this starts at 0 by default, which is how this is the 0th column and the first column. As a reminder, your index doesn't count as a column, so my first column in this situation is year. So again, arguments to this can be similar to what we did with loc. It can be a list, a slice, or a single value. For a list, again, I'm giving you a list of integer positions in the data. So for the rows, I'm saying I want the integer row position 1, 2, 3, and then I want the integer column position 0, 1, 2. So that's going to be 0, 1, and 2, and that's how I end up with this output. You can also use a slice as an argument to iloc. And in this case, the slice is going to be exclusive of the right-hand side. So this will be your starting value, 0, and then you're going to end actually up at 2, not at 3. And so we can see that here. Here's 0, 1, 2. My last column that I keep is 2, not 3. And the reason that that's the convention is it's consistent with Python lists as well as NumPy arrays. And in each of those cases, that way if you take your stop value minus your start value, you're going to get the number of columns in this case that will show up, will be selected, number of items selected. So that's why that convention is exclusive of one of the sides, and just by convention we always make it exclusive of the right-hand side. Just like loc, we can use a colon with iloc to extract all rows or all columns. And then finally, I can also do a single value for my arguments. And yes, I'm going to get the same situation that I had when I did loc, where this output is going to be a series. And again, that's because it's selecting 1. This is my integer position 1 column. And then I'm looking at integer positions 1, 2, 3. That's where I'm getting this data. And if I just look at the row position 0 and the column position 1, I'm going to extract Andrew Jackson. All right, so let's compare and contrast loc versus iloc. Loc's performing label-based extraction. That's how I remember the naming convention. And iloc is performing integer-based extraction. In general, in this class, when we're choosing between loc and iloc, we'll typically be using loc. This is for multiple reasons. It's safer and it's more readable. It's easier to understand what you're actually grabbing. iloc can still be useful though, and we're going to see a couple of examples, but if you know specifically that you want to grab a certain percentile of the data, then iloc is a good go-to. All right, now, just when it was all making sense, we have a third operator here, just the bracket operator, which was basically designed to give us shortcuts for some of the most commonly used loc and iloc calls. So this extraction operator, the bracket, takes one argument. It can either be a slice of row numbers, a list of column labels, or a single column label. And then what it outputs is context sensitive. So this is really just to give us a shorthand for some of the most common row number slices and some of the most common column label slices we're trying to do using loc or iloc. Let's see some examples. All right, so if I'm just going to give it a slice of row integers, This is going to spit out rows 3 through 7, again, exclusive of the stop value. And so this is equivalent to doing elections.iloc and then saying I want 3 to 7 for my rows and I want all columns. Secondly, I can give it a list of column labels, and then it's going to return all rows and those columns. So this is going to be equivalent to doing elections.loc and then saying, okay, I want all rows, and then I just want these columns. So it's just shorthand. I won't write all 3 of them in there for the sake of time, but you can see the analogy. And I think, did we give it a single column label? If you give it a single column label, again, it would be equivalent. Let's do it in the notebook, actually. We can see that here. Yeah, let's do it here. So there's this one. Here's this one. And then if you get a single column, then it's going to return a series. It would be the same thing as if I had just given it loc. And then I want all rows and just this column. So I'm going to get the same output. So this is shorthand for these 3 common selections, one of them being to select a certain slice of rows and the other 2 to be selecting specific columns. All right, so why would we use just the bracket operator? Again, this is just shortcut. It's just a little bit quicker to write the code, and over time, a lot of typing time can add up. So here's a summary again of loc versus iloc versus our context-dependent operator. In practice, just to save time, we will be using the bracket operator a lot in this course, especially when we're selecting columns. Okay, let's do a little puzzle to end this video. So here I want you to figure out if I'm defining this data frame called weird, and here's what the data frame would look like when it's spit out in Jupyter. Try to predict the output of each of the following. So first, we want weird of the integer 1. Second, we want weird of quotes 1. And third, we want weird of the slice. So take a minute and see if you can match these without trying to run the code. And then we'll come back and check the code. All right, let's look at this in the code. Here's our data frame. And so one of the things you can notice is how we defined it. This first column here has an integer label, the integer 1. This second column here, this label is a string. And so if I just call weird and I don't give it a slice, then it's going to be interpreting what I give it as a column. And so it's going to say, okay, I want the column with label integer 1, and that's going to be this first column, top dog, bot dog. Secondly, I can give it the column with the string 1, and we can see that should then output. Let's do this here. Should output my second column, top cat, bot cat. And then lastly, recall if I am giving it a slice, then I'm going to be getting rows out. And so this is just going to say, pull out all rows, starting at the row with integer position 1. Okay, so in that case, this is my integer position 1, so I should just get that row. That's the only one that I have. Yep, and that's what I get. Because it's saying that row and then to the end, but I don't have anything else past that. So again, this is not a practical data frame. It wouldn't really make sense to define a string versus an integer in terms of what we're doing. We were just trying to help you practice with what these different calls would mean as you're practicing with these operators. And that ends our overview of the ways to select data using these operators. Next up, we'll look at how we can do conditional selections.